5-49. Okay, so this is 5-49. It says David and Regina are competitive racers, and they both aim to break 2 minutes in their respective races. They're trying to figure out who has the more difficult challenge since they compete in different sports. David runs the 800-meter race, and Regina swims the 200-meter freestyle. They agree to accept the following standards for high school boys and girls. The 800-meter mean time, so this is the boys one, right? And this is the girls. This is David, and this is, what's her name, Regina? And so they give us a mean is 149. Stop talking. And a standard deviation is 13.6. And then for the girls, we got mean is 145. Standard deviation is 8.2. I think that's the one for population. I probably should have made a tiny s for sample, but anyway, so currently his time is 202. So here's David. His time is 2 minutes 2 seconds, and hers is 210. And so what is the percentile in which David and Regina each fall? Which one's relatively faster in his or her sport? So this is that one where we go on and we get that, not the easy histogram, but the other one, the normal distribution calculator. And then we type in this. So I'll go ahead and do that. I don't think it'll work for the recording, but well, we'll see what happens. So let's get our little calculator out. So here is, so we have both of them. We have a normal distribution. This one had the y-axis that we liked. This one I kind of like also. Well, it doesn't matter. I'll just use this one. They both will work. And you type in your mean. So my mean for David was 149. And then my standard deviation was 13.6. 13.6. And then he did a 202.
It would be 122.
What?
It would be 122 because that's minutes, not seconds.
Oh, 122?
Yeah.
That makes sense. Does that make sense, everybody? Sorry, thank you for pointing that out to me. Because I was like, those are yucky numbers. Okay, so I want it to be, I think I want to know what's less than that, because that'll give me a percentile. So I think I want to push this one. No, I don't. Do I? That's a sad percentile, though.
Well, you want smaller numbers since it's a race. You want your time to be smaller, right?
Oh, yeah. Yeah, so 0.02, so
I think it's the other way.
2.356. Okay, let's see.
You want it the other way around.
Okay. Thank you, guys. Do I?
Yeah.
Because these are all the ones that were slower than him. Oh, that's confusing, huh? It's because it's like, you know, like how golf, it's better to get a lower score. Oh, man, that hurt my brain a lot. But I think I think you guys that said that, you're right. I think that he actually did better than all these guys because he was a little less time, right? So let's say he's in the 97th percentile, or 97.6 percentile. Let's do that, 97.6 percentile. And then we can grab her, since I already got all this stuff, her stuff, I wrote it down, I know you can't see it, but her mean was 145, and her standard deviation was 8.2, 8.2, and then she got, so 2 minutes and 10 seconds, that's 120, is that 130?
Yep.
Okay. So, 130. And then, do we want to do it like, she's in the 96, so I think he won. She's in the 96.6 percentile. Now I'm going to put it back on the camera, the document camera. So I think he won, and then I can check that. I'm just going to check it in the answer key real quick and make sure. Yeah, David is relatively faster, but the difference is very small. Is that okay? Did people, you guys understand that?
Mhm.
Okay. So, click to stop.